So in this problem, we're asked to find the average value of a function f on the interval from 0 to pi over 2 and all values of x in the interval for which the function equals its average value. So let's start by setting up a definite integral using the average value formula. Now pi over 2 minus 0, of course, is just pi over 2, and 1 over pi over 2 would be 2 over pi. Now the antiderivative of cosine is just sine, and now we're going to evaluate the antiderivative at pi over 2 and 0 by substituting in pi over 2 first. Now here's where your knowledge of the unit circle will be helpful. The sine of pi over 2 is 1, but the sine of 0 is 0. So we're going to get 2 over pi times 1 minus 2 over pi times 0. And of course, anything times 0 is just going to be eliminated, and we're just left with 2 over pi. So the average value in this problem is 2 over pi. Now I'm going to queue up the calculator to figure out approximately where 2 over pi is. So here's the calculator. I'm going to go to the calculating screen and put in 2 divided by pi. And when I get that, I get 0.636, about 0.636. So I'm going to plot this on the graph over here. So here's 0.5, so 0.636 might be about here. So for the second part of the question, where it asks, find the values of x in the interval for which the function equals its average value, what I'm really finding is this x right here. Which value of x on this interval does the function assume its average value? So to figure this out, I'm going to set the function, which is f, or cosine of x, and I'm going to set it equal to the average value, which is 2 over pi. Now we can only really solve a trig equation manually if our result is one of the benchmark ratios, and 2 over pi is not a benchmark ratio. So what I'm going to do is solve it graphically by seeing where the two graphs intersect. So I'm going to cue the calculator back up again, and I'm going to go to the y equals screen, and I've already put in cosine of x, which is our function, and I've put in 2 over pi, which is our average value. I'm going to graph these. So I have the same graph here that I basically have on the screen, and I'm just going to intersect them by using second, trace, option 5, which is intersect, moving the cursor close to the point of intersection, and then pressing enter 3 times. 1, 2, 3. And when I do this, I get an x value of 0.880 if you truncate, or 0.881 if you round. Remember, on the AP test, you have to use 3 decimal places, either truncated or rounding. So I'm going to put 0.881. So in this problem, we did 2 things. We started by finding the average value, and then in part B, we found the x value for which the function assumed its average value. Let's move on to slide number 4. Okay, so in our last example, we're asked to find the average value of a function on the interval from 1 to 3. So let's start by setting up a definite integral to reflect this average value. Okay, now 3 minus 1 is 2, so we're going to precede our definite integral with the fraction 1/2. Now I'm going to distribute the 4 through on the numerator, and now I'm going to mu, which stands for many over 1. 4x squared over x squared is just the number 4, and then 4 over x squared can be thought of as 4x to the negative 2. And now I'm ready to find the antiderivative. If I'm integrating 4, I end up getting 4x. And now I'll write plus 4. I'll leave some space. I'll raise the power from negative 2 to negative 1 and multiply by the reciprocal, which would be negative 1. And my limits of integration are 1 to 3. But maybe I'll clean this up on the inside a little bit first. And I'll think of the inside as 4x minus 4 over x. Distributing the 1/2 through, I'm going to have 1/2 of 4x, which is 2x, and then 1/2 of 4 over x is going to be 2 over x. First, I'll substitute in a 3, which gets me 6 minus 2/3, and then I'll subtract from that the result of plugging in a 1, which gives me 2 minus 2. Now 2 minus 2, of course, just goes away. That's 0. So we're really just left with 6 minus 2/3, which is 5 1/3, or if you prefer, 16/3. So 5 1/3 or 16/3 is the average value of this function on the interval from 1 to 3.